Okay, so section 1.6 is the last section in chapter 1. Yay! About pairs of angles. In previous course, you all have studied complementary and supplementary angles. Have you heard of them before? Complementary angles, two angles that add up to be what? 90. Oh, that goes right here. And supplementary, two angles that add up to be 180. Notice that this is two angles. It is not three angles. It is not 8 angles. It is two. There might be different ways of remembering which one's which, but the way I was taught is complementary and supplementary. They're in like alphabetical order, and the 90 comes first, then the C comes first, number 90 comes first. Adjacent angles are two angles that share a common vertex and side, but have no common interior points. So adjacent angles would be, I'm going to give you another example of adjacent angles here. Like this orange angle here, and this blue angle here are adjacent angles. They share the common vertex right here. They share that common vertex, but their interiors do not overlap at all. Here's another example. Example 5 and 6 are adjacent angles. They're next to each other. They share a common vertex. They have a common side. And then 7 and 8 are non-adjacent. Okay, when you're ready, turn it over. In the figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles, and we're going to explain our reasoning. I'm probably going to explain in talking instead of writing it all down right now because of time. It takes me a while to write. But in this picture, we need complementary, we need supplementary, and we need adjacent. If you get a hand cramp from writing so much in your proofs, I will start showing you abbreviations that you can use in your proofs. If we ever want to write the word angle or angles, you can draw an angle with a little arc through it. That way you don't have to write that 5-letter word a million times. So that's one abbreviation we can start doing. Okay, complementary angles. They have to add up to be 90. Do we have any complementary angles here? Ryan, do you see any complementary? No? Okay, well, we're going to try harder because they're going to add up to be 90. Can the 127 be one of them? No. Okay, so what could maybe be one of them? Okay, so we have to name this 37-degree angle. Can I call it angle A? No. Why not? Who said no over here? Apni. Apni. A is a vertex.
So, like, I'm not explaining it here, but not enough. Because it's CAB, because that's like, you can't do it.
She needs some help. She knows you can't. Lynn?
Because it makes 2 different angles.
Actually, 3.
If you say A, it won't specify.
It's not specific enough. Okay? Yes, because it could be the 127. It could be the 37, or it could be the 164 if you add them together. Okay, so angle, what did you say? CAB? CAB, and so now that's 37. To make 90, what do we add to it? Austin? What do we add to 37 to make 90? Complementary is 90. You really don't have to think that hard. It's in the picture. It's in the picture. Has to add up to be 90 plus 37. Well, I'm going to ask you to use some common sense. Am I going to add 127 or am I going to add 53 to make 90? Right, common sense here. So we need to name this angle. Donovan, can you name this angle for me? RST, good. Now, could I name RST? Could I name that angle S? Why not, Maggie?
Because it's not, it's 2, but not.
Okay, how many angles have a vertex at S?
A lot. Well, it's only that one. I guess you could call it angle S.
You
Yeah,
could.
It's the only one.
Because it's the only
But
one.
if it's attached to another angle, you couldn't.
So you can use angle S
For this.
if you're not for this one, yes. If you're not sure, then just use 3 letters every time. If you're not sure. But you could name that one angle S. Okay. Supplementary angles. That means they have to add up to be what? 180. Thank you, whoever said that. John, do you see any supplementary angles here?
Yes.
Yep. What 2 angles?
And the CAD.
So if we add 127 plus 53, we get 180. What if you can't add that fast in your head and you don't want to be embarrassed if you get called on? Can you use a calculator? Yeah, I didn't say don't take out a calculator. Please use it if you need it. All right, adjacent angles. Adjacent angles is 2 angles that share a common vertex. They share a common side, but they're not overlapping. Rakaya, do you see any?
Angle BAC and
BAC and CAD. Perfect. All right. Example 2, determine the type of angle pair shown. Then find the value of x. I don't know if we're going to do that for every single one. Let's look at the type of angle pair shown. So we've got 3x plus 18 here. We've got 93 degrees here. What type of angles are these? When we add them together, their outside makes a straight line. You had your hand up first.
But you guys don't. Wait, no.
I know, but I want to call on more than just one person, so I call on people who don't even raise their hand. Look how mean I am. I'm so mean. I'm so mean. Alex, you're going to help me though, right? Do you know what degrees this line is?
180.
So if I have this angle next to this angle, what kind of angles are they? They're supplementary, right? Are they also adjacent? They are also adjacent. Adjacent. Because they are not overlapping their insides. They're sharing a common vertex. They're sharing a common side. So they're also adjacent. There's 2 answers for that. How about this one right here? 40, and we've got 6x plus 2. We've got our 40 degrees, and we've got our 6x plus 2. 40 degrees and 6x plus 2. I'm going to look at these, and I'm going to see what kind of shape they make on the outside of them. Because that's going to give me an idea of what they are. Jesse?
Aren't they complementary angles?
They are complementary. Because they add up to be what?
90 degrees.
Right, because they make that 90 degrees right there. Now, there wasn't a box in it. So how did I know it was 90? Maggie?
It's next to one that has a box.
Right. If this is 90, this has to be 90 because together, what do they add up to be? 180, right. Are they also adjacent? Yep. And then how about this one? Same. What's that mean? Complementary and adjacent. Good. We're also supposed to solve these, but time, we've been solving a bunch. I can set them up. How about we set them up but not take the time to solve them? So if they are supplementary, that means I add 93 degrees plus 3x plus 18 degrees, and that equals 180 degrees. When you solve it, you can just do a degree symbol. When you solve it, you can ignore the degree symbol. When you find the value for x, x does not have a degree symbol. When you're done, x does not have a degrees. It's just x equals some number. No degree symbol. We're going to do that. Because it's not the angle, it's just the value of x. It's not the angle. Okay, so they're complementary. We're going to take 6x plus 2 degrees, and we're going to add on 40 degrees, and that's going to equal 90 degrees because they're complementary. Again, you can ignore the degree symbols when you solve it. There, I just dropped them. And then you'll get x equals, and x will not have a degree symbol. And then the last one. Emily, can you help me set up an equation for this last one? Well, an equation is going to have an equal sign, so what's it going to equal when I add them together? 90, right. So in order to solve it, we have to have an equal sign. So you're going to say, what does that equal? Equals 90. And yeah, you'd add them together and solve. All right, and we've got two last vocabulary to go to learn. One is called linear pair. And we actually just did this. We just didn't call it linear pair yet. Linear pair. Linear pair when we have two adjacent angles, and the adjacent angles are supplementary. So they make a line when you line them up. That's a linear pair. They're adjacent, they touch each other, they share a common vertex, and then when you add them up, they equal 180 degrees. They make a line. See that line, the outside of the angles there? And then vertical angles, these are my favorite. I don't know why. They're everybody's favorite angles. If you had to pick favorite angles, this will be it. Vertical angles. Vertical angles are angles that are when you've got two intersecting lines, they are angles that are opposite each other. So in this picture, angle 3 and angle 6 are vertical angles. And angle 4 and angle 5 are vertical angles. Now, something really special about vertical angles is if they are across from each other, if they are opposite each other like this, they're vertical angles, they're also congruent. So when I marked these, I marked them with congruent marks. See, 4 and 6, or 4 and 5, I'm sorry, 4 and 5 have the same congruent marks, and 3 and 6 do. So they are congruent. It says right here. And then you'll add those to your vocabulary packet. It looks like my diagram got cut off. Let me draw the diagram on the next page. I don't know why sometimes when I send this stuff to the copier, things get cut off. No idea. That's not it. What are we doing? We're doing 1-6 notes. Here it is. Oh, maybe because my diagram got cut off. There we go. You have to draw this. I apologize. Here we go. So we're going to draw a horizontal line and then a diagonal line. Oh, you guys aren't seeing it. What can I do? Can I show part of this at one time? Oops. Oh my gosh, you could have totally copied it by now. I was just trying to do this. There we go. I can copy it. All right, so I've got angle 1 is here, angle 5 is here, angle 4 is here. And then I'm going to draw 2 and 3 in there. So in this picture, do we have a linear pair? Two angles that form a line. What numbers? Angle 1 and angle 4 make a linear pair. Angle 1 and angle 4. Is that my only example of a linear pair? Stephen, can you tell me another two angles that make a line together? 1 and 3. Is that what you said? So it's got to be two angles, and their outside forms a line, just like 1 and 4 form a line. What? 4 and 5, right? So 4 and 5. 4 and 5 also are a linear pair because they make that straight line there. Okay, name a pair of acute vertical angles. So two angles that are acute and vertical angles. So vertical angles would be the ones that are opposite each other. Matthew, can you help me with vertical angles?
1 and 5 would be vertical.
Yep. That's it. That's it. Those are the only ones that are acute. What? Yeah, those are the only vertical angles there. And then a pair of complementary angles. Oh no. Was there something that makes 90 in my picture? Do I have a 90 degrees in here? Do I have anything that says anything's 90? Pair of complementary angles. There's no evidence of anything that's 90 degrees. So you can't assume that 2 and 3 just because they look like, or not 2 and 3. 3 and 5 to me looked kind of like they might be 90, but that doesn't mean they are. Unless there was a box in there, which probably should have been, but there wasn't one, so. Okay. Find the missing variables. We're not going to do all the work for these. We're just going to like go over how you would do it. Find the missing variables. So like question A, looks like A is missing and B is missing. You cannot solve for A and B at the same time. You have to do one at a time. So let's just look at A. How could we solve for A? Where's A located? Negative 3A plus 56, there's one. And 5A plus 40. Those are all the equations, all the expressions that have A in it. Lynn, what do I know about these two angles? They're called vertical angles, yes. That means they equal to each other. They're congruent. So we would do negative 3A plus 56 equals 5A plus 40. If they are congruent, then they are equal. And then we would solve that equation for A. That I'm not taking the time to do right now. How about B? How would we solve for B? Aaron, how would we solve for B? Okay, why would you put them equal to each other? Because they're vertical angles, and vertical angles are congruent. Perfect. Yeah, so that they would be equal to each other. That looks good. I think all of these are vertical angles. Let me make up a different example, just making one up. We're not going to solve it because I'm making it up. Okay. If I have this example and I want to solve for x, you guys are going to look up here. Can you read my handwriting good enough? Can you find where my x's are? Here's 1x. 5x plus 2. And then my other x is right next to it. 3x minus 9. So tell me something about these two angles. Are they congruent? I mean, I'm going to look at them and I'm going to say I think congruent. I'm not allowed to assume anything. They're supplementary. How do you know? They make a line. Okay? So if they are supplementary, instead of doing equal, what are we going to do? Plus 3x minus 9 equals 180. So we're just using what we know about supplementary and setting up an equation. Okay? Last example, example 5. Two angles form a linear pair. The measure of one is 5 times the measure of the other angle. Find the measure of each angle. So I read two angles form a linear pair. That's the first thing I read. What would you do? Draw it. Linear pair means line and a pair of angles that make that line. Linear pair, line, and a pair of angles that make that line. Here we go. We got angle 1 and 2. One angle is 5 times the measure of the other angle. If I don't know the measure of the first angle, how can I find 5 times the measure of that? Can't. If I don't know the measure of the first angle, what do we do in algebra? This is geometry, but what do we do in algebra if you don't know something? John? I'm going to make a variable for an unknown number. Which one should be the x? Because you said 5x. Which one should be the x? Look at my picture again. If the other one's going to be 5x, which one in my picture should be the x? Why? Because I said, look again?
But, because it's supposed to be, like, more than the other one.
Yeah, 5 times more, right? So that one's going to be the 5x. So if I do 5x and x, how can I solve it? How can I set up an equation? What do I know about a linear pair? What do I know about these? Abby? Right, linear pair, they're supplementary. So they equal 180. And then we could solve that, and we get x equals 30, and then 30 times 5 is 150. All right, I have the worksheet I've already handed out. That is your assignment. I'm also handing out, which I forgot to do earlier, I'm also handing out a weekly review.